In the last presentation, we did the analysis of clock sequential circuits with D flip-flop, and in this presentation we will continue the analysis with JK flip-flop. And I have taken the circuit in which there are two JK flip-flops, the A and the B. These are my two JK flip-flops, and in this circuit, in this sequential circuit, you can see there is input combinational logic, but there is no output combinational logic as compared to the last presentation. So our task is easier. Why? Because we don't have to worry about the output equation. The output is simply the output of these two flip-flops. That's why we don't have to find out the output equation. We have to only find out the input equation. So our task is little bit easier, but at the same time our task is tough because we have to find out the next state values depending upon the values of the JA, KA, JB and KB. You will get this thing when we will move to our state table. So without wasting any time, let's move to our step 1. STEP step 1. In step 1 we will find out the input equation, and the input equation is nothing but the expression for JA, KA, JB and KB. So first I will find out the expression for JA, which is very simple. It's simply QB. You can see QB is connected to JA, so JA is equal to QB. Now I will find out the expression for KA. K is what? It is the output of this AND gate, and the two inputs to this AND gate is JA. Here it is JA, and this input is X complement. X is my input. X is my input, and I have taken the complement and then I have given it to this AND gate. So the output of this AND gate is X complement JA, which is equal to KA. So I will write KA equals to X complement JA. We are done with the A flip-flop. Now we will move to the B flip-flop. First I will find out JB. It is equal to X complement, and KB is the output of this XOR gate. Let's see what are the inputs of this XOR gate. The first input is QA and the second input is X. So the output is X XOR QA. So KB is equal to X XOR QA. This is my odd ones detector. I can also write it as X complement QA or QA complement X. So we are done with our step 1, in which we have find out the different expressions for our different input. Now we will use this to find out our state table, and finally by using the state table we will have our state diagram. Now I will copy these expressions so that I can paste it near to my state table, and I will use these equations to fill the state table. So copy and then paste. Now let's take it near to my state table. I have already made the state table so that we can save some time. Okay, it will work here. Fine. Now you can see the present state is QA QB. X is my input and QA plus QB plus is my next state. So let's find out what is the next state by using the characteristic table of the JK flip-flop. For that we have to find out the values of JA, KA, JB and KB. So let's start with JA. J is what? It is simply QB. So whatever be the value of QB, it's going to be JA. So I will copy QB and I will paste it here. Now we will see for KA. KA is X complement JA. So let's check what we have. X complement JA. Here this is X, this is JA. The complement of 0 is 1 and it is ended with 0. So it will give us 0. 0 0 will give us 0 again. 1 1 will give us 1. 0 1 will give us 0. 1 0 will give us 0. 0 0 again 0. 1 1 it is 1, and finally 0 and 1 is 0. So we are done with JAKA. Now we can find out the next state values of A flip-flop. So let's do it. You already know the properties of the JK flip-flop or the truth table of the JK flip-flop. So by using it, we will find out the next state. And let's check for this first case when QA is 0. We don't have to see QB because it is the present state of B flip-flop. We have to find out the next state of A flip-flop. So we have to see the present state of A flip-flop. So we will see QA. QA is 0 and JAKA both are 0. It means the memory state, the next state is going to be 0. So QA plus is 0, and for this case QA is 0 and JAKA are again 0 0. So again the memory state, QA is 0, JA is 1, K is 1. It means toggling, and in toggling we just take the complement of the present state. So 0 is the present state, taking its complement I am having 1, and for this case QA is 0, J is 1, K is 0. So simply QA plus is 1, again 0 0, that's why memory state QA is 1, so it's going to be 1, 0 0, memory state QA is 1, again it is 1, and 1 1, toggling 1 is the QA, so complement of QA is 0. So because of toggling I am having the next state as 0, and for the last case 1 0 and the QA is 1, no problem, the next state is going to be 1. So to fill the values of next state, you must know the truth table of the JK flip-flop. If you don't know it, I cannot help you here. You have to remember the truth table for the JK flip-flop. If you know the characteristic table, it will work, but if you know the truth table, you know how we are filling these values. So we are done with the A flip-flop. Now we will move for the B flip-flop, and for that we have to find out JB and KB. JB is X complement, so it's simply the complement of all these values. So I'm having 1 0 1 0 1 0 1 and 0. KB is the XOR combination of X and QA, so it is simply the odd ones detector. So we will see the odd number of ones in QA and X. Let's start with it. 0 0, it means no ones, so 0 is here. 0 1, odd one is there, so 1. 0 0, again 0. 0 1 is 1. 1 0 is 1. 1 1, even number of ones, so 0. 1 0 is again 1, and finally 1 1, even ones are there, so 0. Now we are done with the JB and KB, the two inputs of our B flip-flop, and by using it we will find out the next state, that is QB plus. So let's start with it, and we will now see the present state of the B flip-flop, which means QB. So QB is 0, JB is 1, KB is 0, it means QB plus is 1. QB is 0, JB is 0, KB is 1, it means 0. Again 1 0, it means 1. 0 1 means 0. 1 1 is toggling. Toggling means the complement of the present state. Present state is 0, and we will take its complement, so it will give us 1. 0 0 is memory state, 0 is the present state, so we are having 0 as the memory, and 1 1, again toggling is there. I have to take the complement of 1, so it will give us 0, and finally 0 0, the memory state. Present state is 1 and it's going to be 1. So this is the complete state table. We are done with the step number 2 also, and the final step is to make the state diagram by using this state table. And as there are 2 flip-flops, there are total 4 possible states, and these states are S0, which is 0 0, QA, QB, S1 is 0 1, S2 is 1 0, and S3 is 1 1. I will make these states here, and by using this state table we will see the transition in the state diagram. So these are my 4 states. Okay, and this is S0, so 0 0, this is S1, 0 1, this is S2, 1 0, this is S3, so 1 1. Now let's see for the first case when the input is 0 and we are on S0. 0 0 means we are on S0, we are here, and the input is 0. So the next state, that is QA plus and QB plus, is 0 1. So from 0 0 we are going on 0 1 like this, okay, and the input is 0 simply. Now we will see for this case, when we are on 0 0, it means S0 and the input is 1. In this case the input was 0 and it drove us from S0 to S1. Now if I make the input 1, what I am getting is the same state. The next state is same as the present state, so I am going to be on S0 when the input is 1. And when I am on S1, 0 1 is my S1, and if I make the input equals to 0, I am going on 1 1. It means I am going on S3 if I make the input equal to 0. And when input is 1 and I am on S1, the next state is 1 0. It means it is S2. So I am going to be on S2 from S1 if input is 1. Now let's check when we are on S2 and the input is 0. We are going to be on S3. So from S2 I am going on S3 when input is 0. And when I am on S2 and input is 1, I am going to be on S2 itself. So the same state if the input is 1. And for the last case, when I am on S3, that means 1 1, if input is 0, I am going to be on S0. Wow. So this is S0 when input is 0. Final case, when I am on S3 and if input is 1, I am going to be on S3. So I am going to be on S3 if input is 1. So this is the complete state diagram for the circuit that I have made, and this is a proper way to deal with the sequential circuit. In this case we have to do a little bit of extra work because of this next state. We have to find out this next state depending upon the values of JA, KA, JB, KB, whereas in case of D flip-flop, the next state Qn plus 1 is simply equal to the value of D. So there is no need to see the present state and see the values of JA, KA or JB, KB. This is the extra work that we have to do in this presentation. But we were lucky that we don't have to find out the expression for Y. Otherwise there may be one more column for Y, that is our output, and we have to see for the output also. So that must have taken 4 to 5 extra minutes of ours. So this is all for this presentation. I will end it here. See you in the next one.